Good day, viewers. In this section, we are going to look at some few examples to illustrate how to apply Kirchoff's law to analyze circuits. We have our two Kirchoff's law, the current law and the voltage law. For current, we have to assign current sections of our given circuit and also identify particular junctions where currents are approaching or leaving. Two, to apply the Kirchoff's voltage law, we have to also apply loops in our circuits so that we can make use of the loops to write down equations that are in agreement with the Kirchoff's voltage law. So we are given this circuit. To start using Kirchoff's, we have to assign current to the circuit. So we can say we have one current here. We can call this current I1. Let's say we have another current here which is moving here, which is I2, and we can assign another current here, I3. Take note, the assignment of the current, the number of current I1, I2 is not going to affect your results, and also the direction of the current is not going to affect your result. Finally, when you finish, you have to interpret your results. For instance, if at the end of our solution we obtain I1 to be negative, it means the direction of the I1 is the opposite direction of the one is opposite of the one we have taken. Similarly, if I2 is negative, then the direction of the current is this side, and so on. Then we have assigned currents to our section. It means that we have a point, a junction here, which is going to split our current. So this junction, we can call this junction Q. This will now enable us to write the Kirchoff's current law, because we have a junction and we have currents. Okay, that is first procedure. The next procedure is we look at how many loops do we have. Here we have about 3 loops. We have a loop here. A loop is a closed circuit that contains our electrical elements. So here is a loop. Here is also another loop, and we can also look at the entire circuit as a one loop. So we can choose this loop as one loop, loop 1, and we can also choose this as loop 2, meaning that I'm going to start from 3 ohm resistor, coming down here, going to 6 ohm, and going back. This will give me a closed loop. Similarly, here my loop 1 is going to consist of 6 ohms, 12 volt battery, and 4 ohms. So this is my, and I've decided to choose clockwise direction. You can choose anti-clockwise direction, and that will not affect your final result. So with these 2 steps implemented, we can now consider writing the Kirchoff's voltage law and Kirchoff's current law. So starting with loop 1, which is clockwise, I'm going to write the KVL here. So here I'm going to write KVL, that is Kirchoff's voltage law. Kirchoff's voltage law is talking about closed loop. So I have a closed loop here consisting of 3 items here. So I'm going in the clockwise direction. So we need to remember one thing again here, that the condition for writing, the criteria for writing your potential voltage is such that if I'm following my loop, the terminal I meet first of my battery is the sign of my potential. The terminal I meet, this is for potential. Well, my potential drop across my resistor is such that if my current inside the resistor is in the direction of my flow of my loop, it means the potential drop across the resistor is positive. Okay, but if it is against my direction of going around the loop, then the potential drop is negative. So with these 2 things, we can now consider loop 1. Considering loop 1, we can see that if we are starting with the battery, when I'm going in this direction, clockwise direction, I'm going to meet the negative terminal of my 18 volt, and therefore it is minus 18. Then plus, my current I1 is in the direction of my loop, therefore my drop 4 times I1 is going to be positive. That's why I put plus 4i. Similarly, when I'm coming down to 6 ohm, my I3 is in the direction of my flow, therefore the potential drop across 6 ohm resistor is also positive. So when I put all these things, I have summed all the potential drop in a closed loop. Here the Kirchoff's voltage law says that the total sum is going to be 0. So this is my equation number 1. In the same way, we consider equation loop 2. In loop 2, I'm going also clockwise. So I will start with my 6 ohm resistor. You can see that my loop 2, I'm going clockwise while the current I3 coming through the 6 ohm is against me. Therefore, the potential drop across 6 ohm resistor is going to be negative, and that's here. And my I2 is in the direction of my 3 ohm resistor, my loop, okay, the direction of my loop clockwise, therefore it is positive. Also, this in my closed loop consists of only 2 items, 3 ohms and 6 ohm resistor. So this sum will also be 0. So this is my equation number 2. Now coming to my junction where I will write KCL. So here is also KBL, and here is going to be KCL. Kirchoff's current law. Kirchoff's current law is about a junction. So I'm considering junction Q. This Q, at this junction, I am saying the algebraic sum of current at this junction is going to be 0. Therefore, my algebraic term means that if I assume coming current to be positive, then leaving current will be negative. Now I'm considering coming to the junction positive. Therefore, my I1 is coming to the junction, and therefore it is my positive I1. But my I2 is leaving and I3 is leaving, so they are all negative. So this sum must be 0. This is my case here. So these are my 3 equations that will, when I solve them, I am going to have detail about the current and potential drop across the closed circuits and the resistors. Okay. When we look at equation 2, let's look at equation 2. We can easily see that equation 2 is going to give us this equation. That if I take minus 6i2 to the right hand side, I'm going to get this equation. 3 cancel and 6 will give me 2. So I'm going to have I3 to be equals to 2i2. This is from my equation 2. Okay, and if I substitute this equation 2 into my equation 3, putting this into equation 3, because I am going to remove I3 and put 2I2. So minus 1I2 minus 2I2, because I3 is 2I2, as you can see here. Therefore, this will give me minus 3I2. So minus 3I2 coming to the right hand side is going to be plus 3I2. So I'm going to get this equation from using this equation and equation 3. So with this information, I will now substitute these 2 results into my equation number 1. Okay, I will substitute this and this so that I can find I2. Okay, removing I1, I'm putting 3I2. I'm going to have 12I2 here. 12I2 plus 6I2, I'm going to get 18I2. This minus 18I2 is going to the right hand side, so it becomes positive. Therefore, I will have 18I2 equals to 18. That will give me I2 equals to 1. Then I now walk backward. If I2 is 1, I3 is going to be 3 times 1, which is 3 amperes. Then if I also substitute in the above equation, I3 is going to be 2 times I2, which is I1, so I'm going to get 2 amperes. So this will now give me all my unknown currents in the circuit using Kirchoff's current law. So this is the end of this questions. Let's see an additional example. Okay, here is a second example. In this example, we are given two voltages here, 2 batteries. We have 6 volts and we have 12 volts and 2 resistors, 100 ohms and 200 ohms. Here we are asked to find the current and the direction of the current inside the 2 ohm resistor. So in the normal way, we also identify a junction here. So this is the junction. This is the junction. We assign current. So let's say we assign currents. Okay, let's say we have current here, I1. We have current here, I2. And let's say we have another current here, I3. Okay, then we have to identify our loops. So let me change the color. So I can consider this as my loop 1 anti-clockwise, and in this case I want to choose this as my loop 2, which is anti-clockwise. Okay, so my adjunction here, let's call this junction phi. At junction phi, I can write my KCL. At P, I have the KCL, okay, Kirchoff's current law at P. So I will assume that current coming to the junction are positive. So therefore, I have I1 coming plus so it's going to be minus I2 because I2 is leaving, then plus I3, which is also coming to the junction. So this KCL give me that this is my equation number 1. Okay, then I will now take the KBL at loop 1. Now loop 1, I'm going to write KVL. Okay, so I'm taking my current in my loop in the clockwise direction. So I'm meeting the positive 6 volt first, then plus the potential across the 200 ohm resistor is in my direction. My current in 200 ohm resistor is in the direction of my loop, therefore is positive. So I'm going to have 200 I1, and when I come to this, my current in 100 ohm I3 is in opposite direction to my loop, therefore is going to be minus 100 I3. So this is my equation number 2. Okay, maybe I will take loop 2. I will also write I'm going to write KBL here. So in loop 2, I'm taking my loop 2 anti-clockwise moment. So starting with my 100 ohm resistor is against my current, my loop. So it's going to be 100 minus 100 I3, because I3 is going up while I'm coming down. Then I'm going to meet my battery. So my battery, I'm coming to meet the negative terminal first. Therefore, my battery is going to be 12 volt. Okay, this sum is going to give me 0. Okay, sorry, I should not write the volt here. So it's just minus 12. Okay, minus 12 is going to be 0. Okay, so with these 3 equations, this is my equation 3. Okay, equation 3. So you can easily see that equation 3 is going to give me I3 to be equals to the 12, when the 12 to the right hand side is going to be positive 12 over my 100. So it's going to be minus 100 ampere. So this is my I3, minus 112 over 100 ampere. This is my I3. Putting I3 into equation 2 is going to give me equation 2. I'm going to have 6 plus 200 I1, okay, minus, so this minus and this minus will cancel, 100 will cancel 100, so I'm going to have plus 12 here to be equals to 0. This minus cancel minus, this 100 cancel 100, so I'm going to have 12. So this is now telling me this and this is going to be 18, so it's going to say I'm going to have 200 ampere, 200 I1 equals to minus 18. 6 plus 12, 18. 18 to the right hand side, it becomes negative, such that my I1 is now going to be minus 18 over 200 ampere, which can be simplified to minus 9 over 100 ampere. So this is my I1. So I got my I1, and I also obtained my I3. So what remains is I2. So coming back to insert the values of I1 and I3 into equation 1, I can be able to get I2. So taking I2 to the right hand side is going to give me I2 is going to be I1 minus plus I3. So my I1 is minus 9 over 100, then plus I3. I3 is also minus, so it's minus 12 over 100. Since I have the same LCM, therefore I1 is now going to be minus 21 over 100 ampere. So what does this mean? All my currents are negative. It means that the assumed directions, all my assumed directions are not correct. So I1 is supposed to be flowing this side. I3, instead of following of the correct value of the direction of my I3, is going to be down. And since I2, I obtain I2 to be negative, then this direction I assume is not correct. It means I2 is going to flow in this direction. Okay, so this will give us the second example, which involves two batteries. Okay, let's have another example.